Welcome to a lesson on graphing the square root function and reflections of the square root function. Let's start by considering the basic square root function f of x equals the square root of x. We want to state the domain and then graph the function. The domain is the set of all possible inputs or values for x. So for the square root function, the number underneath the square root cannot be negative. Therefore the domain are all values of x that are greater than or equal to 0. Now to graph this function, we'll complete a table of values. We'll select x values, perform substitution, and then determine the corresponding y values. And since we'll be taking the square root of x, we'll select x values that are perfect squares. For example, 0 squared would be 0, 1 squared would be 1, 2 squared would be 4, 3 squared would be 9, and this should be enough to make a nice graph of the function. So when x is equal to 0, y is going to be equal to f of 0, which would be the square root of 0, which is 0. Next, when x is equal to 1, y is going to be equal to f of 1, which would be the square root of 1, which is 1. Next, when x is equal to 4, y is equal to f of 4, and the square root of 4 would be equal to 2, since 2 squared is equal to 4. And then when x is equal to 9, y is equal to f of 9, and the square root of 9 is equal to 3. So if we plot these 4 points, we should be able to make a nice graph of the function. So we have the point 0, 0, the point 1, 1, the point 4, 2, and the point 9, 3. So here's the graph of the basic square root function. Now we'll take a look at functions that will reflect this across the x-axis and y-axis. Again, we want to state the domain and then graph g of x equals a negative square root x. We'll notice we're still taking the square root of x here, so the domain is still going to be x greater than or equal to 0. So because of this, we're going to select the same values of x that we did when graphing the basic square root function. So we'll select 0, 1, 4, and 9. Notice our graph already contains the graph of the basic square root function, so we'll easily be able to compare how this function has changed from the parent function. We'll notice when x is equal to 0, our function value is still going to be 0. But then when x is equal to 1, y is going to be equal to g of 1, which is equal to negative square root 1. So now the output of the y value is negative 1. When x is equal to 4, y is going to be equal to g of 4, which is negative square root 4, which will be equal to negative 2. And then when x is 9, y is going to be equal to g of 9, which will be negative square root 9, or negative 3. So notice how for g of x equals negative square root x, having the negative in front of the square root ends up changing the sign of the y coordinates. So if we plot these points, we'll have the point 0, 0, 1, negative 1, 4, negative 2, and 9, negative 3. So here's the graph of the given function, g of x equals negative square root x. Notice that because this function changed the sign of the y coordinates, it's a reflection across the x-axis. Now let's consider the function h of x equals square root of negative x. So now notice the negative is underneath the square root. Well, this is going to affect the domain. In this case, negative x must be greater than or equal to 0. So if we were to solve this for x, we would divide both sides by negative 1. Remember, when solving an inequality, if we divide by a negative, we have to reverse the inequality symbol. So in this case, the domain will be x is less than or equal to 0. So we'll have to use this information to make sure we select the appropriate x values to complete our table of values. So we'll still select x equals 0, but notice how we cannot select 1 because that's not in the domain. But if we select negative 1, we'll have a negative 1 underneath the square root, which would be positive 1. So we'll select -1, -4, and -9 this time for the values of x. So again, when x is equal to 0, our function value or y value would be 0. But now when x is -1, y is going to be equal to h of -1, which is going to be the square root of -1, or the opposite of -1, which ends up being the square root of 1, or 1. Next, when x is equal to -4, y is going to be equal to h of -4. So we'll have the square root of -4, which ends up being the square root of 4, or 2. And then lastly, when x is -9, y is equal to h of -9. So we'll have the square root of -9, or the square root of +9, which is 3. So notice here, when we have the square root of -x, the result is the x-coordinates have changed sign. So if we plot these 4 points, we have the point 0, 0, -1, 1, -4, 2, and -9, 3. Notice based upon the parent function f of x equals the square root of x, h of x is a reflection across the y-axis. So let's summarize these reflections. If we base our information on the basic parent function f of x equals the square root of x, if we have y equals -f of x, this will be a reflection across the x-axis. This was our example in green where we had g of x equals -f of x, which was equal to negative square root x. Again, notice how this changed the sign of the y-coordinates, therefore reflecting the function across the x-axis. And then if we have y equals f of -x, changing the sign of the x-coordinate, this reflects the function across the y-axis. This is our function in red, h of x equals f of -x, which equals the square root of -x. This changed the sign of the x-coordinates, and therefore was a reflection across the y-axis. And to view all of this graphically, here's our parent function, f of x equals the square root of x. Here was g of x equals negative square root x, and here was h of x, which was equal to square root -x. So it is helpful to be able to look at a function and know how it's different from the parent function, but of course if needed, we can rely on completing a table of values to graph our functions. I hope this was helpful.